Cool. So thanks everyone for coming. Today I'm going to be talking about Compose Multiplatform accessibility. And before we jump into that, hey, I'm Colin Marsch. I'm an Android engineer at Cash App. And while I don't work directly on Compose Multiplatform things at Cash App, we do use Kotlin Multiplatform quite heavily in different parts of our application. As well as I'm part of our accessibility working group. So sort of combining two of these things into Compose Multiplatform accessibility for this talk today. So as a bit of an overview, we'll start off with sort of overview of what is Compose Multiplatform, how it constructs UI, accessibility handling and how it does that, and testing for how we'll make sure that our applications are accessible on both Android and iOS. So firstly, what is Compose Multiplatform? So just from a share of hands here, how many people have heard or are familiar with Compose Multiplatform before today? Okay, got a few. Okay, that's good. So at a high level, Compose Multiplatform is a multi-platform UI framework to be able to ship UI on 4 platforms, Android, iOS, web, and desktop, using Kotlin code in the Jetpack Compose style of declarative UI put out by Google. So Compose UI itself is a native Android UI framework made recently. Probably it's sort of the newer style of building Android UI. And Compose Multiplatform builds upon that to allow Compose UI to ship to other platforms other than Android. So like I mentioned, iOS, web, and desktop. Specifically in this talk, I'm just going to stick to the mobile platforms, Android and iOS. They're a bit more familiar for me and more similar to each other as well. So just to contrast a bit as well, Kotlin Multiplatform is a bit of the underlying technology that Compose Multiplatform builds upon. And if you think of Kotlin Multiplatform on its own, its main goal is to enable shared logic between your platforms. So you can write your business logic in Kotlin, publish that as a Kotlin module, and consume that in both of your Android and iOS applications. So for example, you could do some sort of date formatting, or just as a simple example, then have that be consistent between your Android and iOS apps and not have to worry about any things being duplicated, have to do the work twice, or any issues coming up from just implementing it wrong on one platform or the other. So to contrast that with Compose Multiplatform focuses on the UI side of things. So it enables developers to write their Jetpack Compose code in Kotlin and then deploy that to Android and iOS platforms, declaring or showing the same UI on both applications with only needing to write it once in a shared place. So here's just a little snippet of some Compose code where we have a button that is pressed to toggle this show image state variable. And then an image is either shown or not shown depending on the state of that variable. So this is something that would work out of the box on native Android, and you would just get a UI that handles this. On iOS, though, you would need to do something different than this. But with Compose Multiplatform, you don't. So you can use the same Compose code here on both platforms. So from this little video, we can just see the exact same UI running on Android and iOS from the code of the slide before. So how does Compose Multiplatform actually build this UI? Because on both platforms, Android and iOS, there's quite different styles of how we would anticipate that the UI is actually drawn in the app, and we might build different UI elements very different ways. Especially iOS is mostly written in Swift or Objective-C, so that's much different than Kotlin, which is sort of Android's primary language. And the interesting part here is that for Compose Multiplatform on Android, it's just regular Compose UI. So there's nothing special going on the Android side. Compose UI on Android is the core of Compose Multiplatform, and Therefore, it's still used the same as it would be on native Android. So even, for example, if a company were to go down the route of building a Compose multi-platform app, and then somewhere along the way decide, maybe this isn't really working out for us, you still have a fully functioning Android app. So you don't need to worry about that. Maybe you want to rewrite your iOS app at that time, but you still have everything you need for a fully native Android app. So if we look at this code, we are just setting up the main activity, which is the main entry point to an Android app. And here in this set content function, we pass in this app composable function, which represents the UI of our app, the root UI. This is the exact same function that you would call if you were calling native Compose UI in an Android app just built fully using Compose UI with no multi-platform components. So this would be identical to how you would do that on a native Compose Android application. If we take a look at what's actually generated here, once we get the UI into the app, on the left side, we have a screenshot of some widgets, some text and things arranged in different orders and rows and columns. And then on the right side, we have the actual components that are showing up when we use the Android Studio layout inspector to see what the UI of our application actually consists of. So here we can see that it's all just the basic components from Compose UI as we would expect. We have rows and columns, which are sort of the main layout components, text, which just shows text, and then some other spacers and things just to make the things fit a bit better on the screen. But overall, it's just nothing special here compared to regular Compose UI. But what about on iOS? So there's no Compose UI for iOS natively. So there's got to be something a bit special that Compose Multiplatform handles under the hood to be able to deploy this UI on iOS as well. If we take a step at just the first, take a look at the first entry point to the app, this might look pretty similar to what we showed about the main activity entry point on Android. This is just a sort of simple looking function declaring a Compose UI view controller. A view controller can be thought of as analogous to an activity on Android as an entry point to the application. And here we're just passing in the exact same app composable function, which contains all the UI that we're using on the Android app. The one difference here is that this Compose UI view controller is doing some complicated things under the hood to be able to actually display this Compose UI in the iOS application. So if we dig a few layers down into this Compose UI view controller, we get to a lot of usages of this Colin multi-platform library called Skiko. I've actually never heard this word said out loud, so I'm not sure if I pronounced that right. But Skiko is a Colin multi-platform library to be able to use the Skia rendering engine to draw directly to a canvas. For Compose Multiplatform's case, it uses this on iOS to draw by default, the material design versions of all of the components that you're using in your app. So things like the buttons and whatever else will just be the general material styling, as we sort of saw in the previous video with the purple toggle button for the image. So Skiko just draws to the canvas on the iOS side with no native iOS UI elements by default there. There's some pros and cons to this though. One of the pros is that we will have fully identical UI between platforms. Since we're just drawing straight to the canvas, there's not going to be any difference between our Android app and our iOS app, as we're just putting pixels on the screen and not worrying about any sort of platform differences there. The UI won't change during any OS version updates. So for example, if a user updated their Android or iOS phone, sometimes the styling of buttons and things like that could change in different operating system versions. And with this canvas approach, there will be no change based on the operating system version. We also have less platform-specific code to worry about, since it's just the general Colin multi-platform library that enables this Skia rendering. There's not really too much iOS-specific code going on, aside from some of the canvas itself pieces, but a lot of this sort of limits the amount of iOS code that needs to be written. On the con side, however, there is a possible performance overhead to this, especially if we have a lot of state changes going on in our application, or we need to do a lot of redraws for those kind of cases. So that is possible in some instances. As well, if we want to integrate native iOS UI alongside the Compose Multiplatform UI in the iOS app, this introduces some extra complexity, especially if we want that UI to be on the same screen. So this is supported by Compose Multiplatform, but it has a few extra hurdles to go through that I'll chat briefly about in a bit. And finally, for our main point here, this introduces some accessibility complexity. Since we're not using any of the native iOS UI elements, and we're losing all of the baked-in accessibility support that they have, this is a very more complicated situation to have to recreate all the accessibility information that is needed to ensure that our buttons and hierarchy are all accessible for our customers on both platforms. So now just to briefly touch on the native iOS UI interoperability I mentioned. Compose Multiplatform does allow developers to use native iOS UI elements in their Compose Multiplatform code. So in this case here, there's this UIKit view compose function that we're using that just wraps this MK map view, which is a basic iOS map view, just display a map of a location. And we can just pull this into our Compose Multiplatform code here and use it like we would any other composable. Sort of similar on the Android side if we're using something like an Android view, just to pull in something from the more legacy view system. And you can also use SwiftUI. There's a bit more complicated setup there to get that in there, so I'll exclude that for now, but it is possible if people want to include SwiftUI, which is sort of the newer way of developing iOS UI. Now let's get to the accessibility part here. So how is Compose Multiplatform related to accessibility? Overall, when you're building UI, that's the time of your application that you really want to be thinking about the accessibility of the app, as that's when you have all the control over the over the UI and its interactions that customers will go through. So this is really the phase where you want to be thinking about accessibility. As well, like Compose provides a lot of accessibility support and APIs that enable very rich accessible experiences to be built natively on Android. And we are able to use a lot of the same APIs, or actually all of the same APIs, in the Compose Multiplatform side as well. So to start by looking at how this works on the Android side, I want to talk a bit about the Android accessibility tree. On Android and iOS, the way accessibility works is through a tree of nodes of information that represent each of the UI elements or groups of UI elements that are displayed on the screen. So each of these nodes will include some information that screen readers, oh, thank you so much. Here, I'll take a drink. Yeah, each of these nodes will include information that enables assistive technologies like screen readers to have everything they need to be able to describe the UI of the app to customers. On the Android side, the data type that is sort of the structure of this tree is the accessibility node info. This contains many of those properties, like I mentioned. The content description, which describes the UI element, whether or not it's selected, if it's sort of a toggle type UI, and if it's important for accessibility at all, or should just be skipped when used with a screen reader. So all of this information is bundled into these accessibility node info nodes that represent the accessibility tree on Android. In Compose, however, there's a bit of a difference where, just due to the structure of how UI is built and the state management of Compose, semantics node is the Compose side of the accessibility tree. So semantics node includes many of the same features, properties that are in accessibility node info, like content descriptions, selection states. Just another example, it includes whether or not an element is a heading, like a title on a screen. And the semantics node is the thing that is sort of emitted from each element on Compose UI and as well in Compose Multiplatform, since it's just built using the same Compose system that we would use normally. So when this is structured, the semantics node that represents all of the accessibility elements, those are mapped to accessibility node info so that the accessibility node info tree is maintained and that screen readers and other assistive technologies will have all the information they need in that main accessibility node info tree and will be able to perform all the tasks they need on the application. So this is kept up to date whenever the state changes or your UI updates or anything like that. And yeah, like I've said before, since Compose UI on Android is used directly in Compose Multiplatform, there's not really any difference here between how this works on Android in Compose Multiplatform and Compose UI. So this is the exact same setup that we would have if we were just building a native Android app using Compose UI. Now let's take a look at the iOS accessibility tree. The overall structure is pretty much the same. It does a tree structure as well. The data type here is the UI accessibility element that is base data type for this tree. It includes all of the similar properties as well. Accessibility label, which is similar to the content description. Accessibility hint, which sort of explains what will happen when you interact with something on your UI. Accessibility traits contains many fields that can be set, like if it's selected or not, or if it's heading, for example. And these are all the same properties for the most part that are available on Android as well. So there is a mapping that must occur here because we are in Compose and we need these UI accessibility elements, which we do not have in Compose. So if we have the semantics nodes and we need the UI accessibility elements, this mapping has to occur, and Compose Multiplatform handles that under the hood as well. So this mapping is also updated whenever the UI updates, your state changes, and it's kept intact so that the assistive technologies will have what they need when they need it for the iOS apps. However, there is one asterisk here that this is only updated lazily on iOS. So to avoid some performance issues that possibly may be fixed in the future, there's only an update made when an assistive technology is connected. So for this tree will not be maintained if there's nothing listening to it, for example. And mapping the iOS properties is something I just alluded to as well. So we will, in Compose Multiplatform, need a way to map the values from the semantics nodes that we have from Compose to the iOS accessibility elements. And I'll take a look here at just a few of those mapping functions that Compose Multiplatform handles. So Compose Multiplatform sort of handles this by overriding the accessibility functions, like accessibility label in this case, in Kotlin, in the actual Compose Multiplatform framework, and just grabs all the values it needs from the semantics nodes of the Compose accessibility tree. So in this case, for accessibility label, it goes through a few steps to figure out what might be good text to have for the accessibility label. Starts with checking if there's a content description, and if there is, then that's used. Or if there's no content description, it'll check if the text is editable text and we have some content in there, if it's a text field, for example, or just if it's got text in it, like if it's just a text composable with some sort of content, that will be used as well. For the accessibility hint, this is something that's a slightly bespoke on iOS. There's not directly a good equivalent on Android. It sort of represents what happens when you interact with an element, but there's not a fully direct mapping. So the usage here is just the label of the on-click action, which is read out on Android when you are interacting with an element. So it fulfills the same use case. There's just a brief snippet of this function. There's many accessibility traits in this function, but I just cut out most of them for the slide. So looking at accessibility traits, for example, if there's a semantics action for the on-click on a semantics node, then we'll set the button trait. Or if we have the heading property set. We'll set the header trait on the accessibility element for iOS. And as I mentioned before, you can also use native iOS UI in your Compose Multiplatform UI as sort of subcomponents. To handle this interoperability, there's a configuration property that you can set to enable or disable the accessibility of the native UI that you're wrapping. So it's false by default, and the accessibility properties are all just pulled from the semantics node on the Compose side. So for this case here, where it is false, the content description here would just be pulled as map of Seattle instead of whatever might be set inside the map view itself on the iOS side. But if we were to enable that setting and use the native accessibility, then that'll put all the control over to the native side. And anything that MK Map View does for accessibility will be represented in the actual state of the application. So this can be good if there's maybe some like tricky situation that's hard to handle in the sort of jump between Compose Multiplatform and iOS. You can fall back to a fully native solution there. Or if you already have something in your app that's really got some custom accessibility actions on it and a lot of code around it that just would be easier to just port in like this instead of rebuilding in Compose Multiplatform, that's an option that's available as well. And now I want to talk about how we test the Compose Multiplatform accessibility for our applications. Just breaking it down by platform. On Android, the accessibility testing for Compose Multiplatform is not different than a iOS or than a regular Android app here. So we can use the accessibility scanner that is app built by Google that you can install on your device or emulator, and just gives you an overlay on the screen, just highlighting some accessibility issues with sort of a pass-fail type style, checking things like if the color contrast is high enough for your text, the touch target sizes are big enough so you don't have any buttons that are really hard to tap on, and you don't have any like missing accessibility labels or things like that. So this is good for a quick way to test out your app. However, it sort of provides a bit of a surface level view of what kind of accessibility issues you might have. There's many that it won't catch, for example, around like the navigation structure of your accessible or accessibility hierarchy. So the next tool that I would recommend is just using TalkBack itself, which is Android's main screen reader. So this enables users to swipe through the hierarchy of UI on their app using the accessibility hierarchy there. And this is where you'll discover if there's any navigation issues, like maybe it's jumping around different places instead of going logically how you would expect it to through your UI. Or there could be interaction issues, like maybe it's never actually getting to the button that you want to click on, or when it does, you actually can't click on that button for some reason, but you can when you're just a regular user in a non-TalkBack situation. Then these kind of issues can be uncovered there to resolve them. And I'd recommend that TalkBack is a part of development workflow, whether it's Compose Multiplatform apps or just native apps as well. And on the iOS side, the tools are similar. We have VoiceOver, which is the main screen reader for iOS, very similar to TalkBack, performs a bit differently in some cases, but for testing purposes is the same. So it kind of cover those navigation issues, any interaction issues, and I'd also recommend this be a part of the workflow as well. The one thing here is that this is mostly easier to use just on a physical device on iOS. Same sort of for TalkBack on Android, however. Either way could work. Accessibility Inspector, however, is a Xcode developer tool on the iOS side that provides this really nice UI here on the right that just provides like a written description of what a screen reader would read out for any of the values that you might have in your accessibility elements on the screen. So it has the label, values, traits, everything like that. This works really well for iOS simulators that you're running on your machine, so you don't have to worry about getting anything onto another app another device as well. And one thing to call out related to the lazily updating of the accessibility tree that I mentioned earlier on iOS, in our Compose UI view controller, there is a configuration option that you'll need to set if you are trying to use the accessibility inspector on the Compose Multiplatform iOS app, as the accessibility tree isn't synced in that case on the simulator because it doesn't detect the accessibility inspector being a accessive technology service that is listening to that UI. If you were to use VoiceOver on an actual iOS device, you wouldn't need this setting, but for the simulator in a local development situation, setting this always property here for the accessibility sync options will ensure that the tree is updated when there's any UI state changes, and you won't have like a long overdue update to your assistive technology values. And that's all I have for today. So yeah, thank you all. And I don't know if we have time for any questions, or maybe afterwards. 3? Yeah, a few minutes. Yeah.
You said like the issue is accessibility, but from what you just explained, what's like an issue with accessibility?
So there is some. I guess I'll start by saying like iOS accessibility in Compose Multiplatform is still in the alpha phase from the Compose Multiplatform side. So that is sort of the potential of that there is bugs there. There are some known in the issue tracker that I've seen, I think some around the navigation hierarchy. And that's the sort of the main one that I've seen there, but potential for others as it's still not in a stable place. Oh yeah.
So you said you can test accessibility, let's say on Android, or doesn't matter on which platforms. For example, for Android, you advise to download accessibility scanner, or you try to use Unpacking. But it seems like it's more of like, let's say, brute force radio testing. Like, isn't there a way to integrate some kind of computer tests? So, like, if you are working with CD, for example, try to write those tests first, and then without using the brute force methods, try to test the accessibility.
Yeah. There are some ways that you could unit test this. I think just recently, actually, Google published the Compose accessibility checks in Espresso. I think it's come through Espresso now. So those should work for Compose Multiplatform applications out of the box. Just in your UI test, you can like turn on those accessibility checks. That's actually the same checks that are used in the accessibility scanner app. So you can just use that in a testing scenario. There's a few like snapshot testing libraries as well for UI that you could use for accessibility as well, to sort of see what the labels are. Like paparazzi is one that comes to mind from Cash App plug there, but there might be some others as well that offer similar features.
I haven't been doing iOS for 7-8 years. Does XUI test work with Compose UI?
It does. Yeah, it does. So Compose Multiplatform has a test tag semantic modifier that you can add. So that uses the same structure as the other semantics properties we've seen here. And then those will flow through to the XCI UI tests. So you can query based on those to run the tests.
Just to clarify, you said you're going to use Espresso in general, like be valid for most of the versions of Compose we have, but you should do it.
I think that would probably only run on Android.
Oh, really?
Yeah. The XCUI tests that Yanji mentioned would be sort of the equivalent on the iOS side. However, I'm not sure about the accessibility testing within that. I'm not as familiar with the library. Thanks.